Okay, our next part of this chapter is about the hormones, plant hormones. There are certain type of plant hormones which allows the plant to respond towards the certain stimuli, like auxin, which is the part of your syllabus. Other than auxin, the plant also have some other hormones like gibberellin, which helps in the seed germination, and they also helps in the blooming of the flower and in the growth of the fruit. Once the fruit has been formed, it grows in the size, the pulp increases. So the gibberellin helps the plant to do this mechanism. And there's another type of a hormone, or you can say there's a gas known as ethene gas, which controls the cell division of a plant, plus helps in the ripening of the fruit. In your syllabus, you only have the hormone auxin. So, what is auxin? Plant produces a plant hormone known as auxin, and auxin deals with the growth. It controls the growth of the plant. Either it's increasing or decreasing, it is in the hands of auxin. Now, let's discuss how the auxin works. So, auxin are produced in the tips of the shoot and root. So location of the auxin production is the tips of the shoot and root. You can see in the tips of the shoot, shoot is a stem, and in the root, right? Because you know the tips are the area where your body or any body extend. If you want to extend any part or elongate any part, you will actually, what you would do, you will stretch the tip, right? Similarly, in the plant, the plant needs to stretch its tip so it can grow, so it can elongate. When they are elongating, that is the growth, right? So, where the auxin are produced? In the tips of the shoot and the root. Now, how do they work? Let's discuss how the auxin work in the shoot. Um, yes, the location or the production area of the auxin is the shoot, the tip of the shoot. As soon as the light falls on the tip of the shoot, the auxin start to be produced, starts to be secreted. However, its working area is not in the tip. They work away from the light. They are produced in the presence of the light, but they work away from the light. They work in the shaded area. They work in the dim light. They work, there is no light present. Or we can say the shaded area, right? What is the shaded area in the plant? The cells which are beneath the tip, underneath the tip. This is the shaded area. This is the area where the light is um, not present in the high concentration. On the tip, maximum light is falling on it, but underneath this tip, you can see the light intensity is not that strong. This is the area where the auxins are actually working. You know, if I need to stretch the tip, right, what I would do? I need to first apply the force on the underneath part, which will allow the upper part of the cells to grow upward, right? I need to extend this lower part, or I need to push this lower part. For example, I'm giving an example. If I need this part to to be extended or to be stretched up, what I would do? Where I would apply the force underneath it. So if I apply the force underneath the cells towards upward, of course the tip will be stretched up. Hmm? So this is the area where the auxin works. How do they work? Auxin are released as sunlight triggers the tip. They released and they will diffuse underneath the cells of the tip or towards the cells, or you can say in the backward direction, or you can say the cells underneath the tip. They will diffuse and they will inactivate or they will initiate the cell elongation, right? What they are doing? Activating the cell elongation or promoting the cell growth. And hence, in the end, what is the conclusion? The tip will extend upward. This is how this auxin works. Okay. In the shoot, now what? Let's go about it again. Auxins are produced in the tips of the shoot and the root. They diffuse to the cells behind the tip and have following effects. See, they diffuse to the cells behind the tip. That is the shaded area. In the shoot, auxin promote cell elongation. That is the growth, right? More auxin, more cell growth, more cell elongation, more growth, right? So auxin in the shoot tip is in higher concentration, more cell elongation, and more growth. However, there's an opposite effect in the root. In the roots, the auxin inhibit the cell growth. So there's less concentration. When there's less concentration, it allows the root tip to bend towards the gravity. Actually, what happens that auxin promotes the growth of the plant in the upward direction. And you know the root grows downward. It has a negative phototropism, right? It grows again towards the gravity. Okay. Now, if the auxins are in a higher concentration, the root tip will start to move upward. This is against its nature. Its main function is to absorb the water. They will follow the water. So, if the auxin is in higher concentration, don't you think it will distract the root and uh, make the plant or make the root to move away from the water? So, in order to prevent that, the auxin are the effect of the auxin in the root is less, so the root can move towards the gravity to uh, uh, to go and navigate the water, right? So less auxin, less cell elongation, and less growth. In the root, auxins inhibit the cell elongation. The amount of the auxin in the root is less, and amount of the auxin in shoot is more. In shoot, it is promoting the growth, and in roots, it is inhibiting the growth. So this is the function of auxin in the group. Okay, now there are certain situations. How does it elongate the control? How auxin control growth in the shoot, right? You know that it is usually made up in the tips of the growing shoot and diffuses to the region behind the tip. They are produced in the tip, but they work behind the tip, right? Okay, and they stimulate the elongation part. Now, there are two scenarios. The direction of the light, right? You have seen certain plants, they have a certain angle. You know, they have bent towards it. If I change the source of the light, the leaves, or you can say the shoot, will move in that direction. They will bend towards that direction. Like in this picture, if you see the first one, see how this seedlings, or how these newly developing plants in the spot, they are in a box, and there's only a small source of light, and they are bending towards it. They're growing in that particular direction. Then in to grow in that particular direction, they have to change their shape. They have to bend towards that, right? How it is doing that? So how the auxin is helping this particular movement of a plant? Let's discuss this. There's a important point I want you to discuss, that is known as, it is a word you have seen in the learning objective, evenly or unevenly distributed. Right? Now, what is evenly and unevenly distribution? You can see there are three pictures, okay? And in this picture underneath it, you can see how these shoots are changing their direction as we are changing the source of light. See how they are moving. So how this process is occurring? Let's go to it. There's something known as equal distribution of the auxin, right? Equal distribution of the auxin. If the sun, for example, the source is the light, right? Let's take the plant is outside in the garden and is underneath the open sky. natural source of light is sun. If it is above the plant, right, above the plant, the light rays are falling on the tip evenly from every side. See in this picture, the sun is above the plant, right, in up straight way. So the light rays are falling over it from all the sides, right? Like इसकी जो रोशनी है ये चारों तरफ से equally पड़ रही है. Now, what we are observing and concluding, the auxin in the tip will be produced and they will be diffused behind the tip cells evenly because the light falling on the tip is from all the sides. It means all the sides of the tip are activated evenly. They will produce the auxin amount evenly and they will diffuse beneath the tip, right? And when the auxins will work in this shaded area, the elongation of the tip will be in an upright position. They will grow up straight direction, right? They're not going to bend anywhere. They will move upward because the light was evenly distributed on the tip. So the plant will move in a upright direction. Okay, it's not going to bend. However, if the direction of the sun is changed, like you can see in this area, the sun moved towards the right side. Okay, so the area where the sun rays are falling, the auxin start to produce in that area and the auxin will move behind that those particular cells. You know, the auxin will always work behind that area where the hormone is produced. ठीक है, ऑक्सिन हमेशा उस जगह पे काम करेगा जहाँ पे प्रोड्यूस हुआ है उसके पीछे वाले सेल्स. ठीक है, उस उस जगह पे नहीं काम करेगा जहाँ प्रोड्यूस हो रहा है. इट ऑलवेज वर्क बिहाइंड द प्रोडक्शन एरिया. ठीक है, प्रोडक्शन एरिया के पीछे वो काम करेगा. सो as the sun direction has been changed, right? So the auxin means the rays are falling in this area on the right side. Auxin will be produced and though they will move towards the shaded area. Do you think now the light is falling on the tip of the plant evenly? क्या चारों तरफ से इसको रेजेस मिल रही हैं? Is the plant providing the ray is the sun providing the rays on the tip evenly? Are they falling on the tip evenly? No. They are on a particular right side. Means left side there are less rays or there is no interaction of the sun on the left side of the tip. Probably on the right side, right? So what will happen? The right side of the plant will now start to produce auxin because that is the area of the activating the auxin and that auxin will go behind those cells. That is the shaded area where they will start promoting the cell growth and cell elongation. Now, due to that, the cell grow. Now the cell will or whatever the cells which are present in that tip or in that area will now start to bend. Okay, means they are growing and making the plant to bend towards the direction of the sun. ठीक है, यानी अब जो टिप है वी आर स्ट्रेचिंग द टिप towards the direction of the sun. So of course if the sun is in the left side, my plant will also bend towards that left side. So is this an equal distribution of the auxin? No, this is unequal distribution of the auxin. See how the plants or shoots are bending in the direction of the light in this picture. Once it was in the left side and then we turn it towards the right side, you can actually see the bending of the plant. So this auxin is actually positive phototropic, right? It allows the plant to grow towards the sunlight. And it's negative gravitropic, of course, okay, which we have discussed in our earlier part. So if we read these points, when light shines on the shoot, predominantly from one side, though the auxin produced in the tip concentrates on the shaded area. You know that auxin works in the shaded area, making the cells on the side elongate and grow faster than the cells on the sunny side or bend. Means the auxin will work in a shaded area, and you can see the bending of the shoot will be towards the sun. Right? This is how it works. This is unequal growth on either side of the shoot causes the shoot to bend and grow in the direction of the light. So if the plant is bending, means it is unequal distribution of the auxin, or if the plant is growing in an upright position, it means the auxin is being produced equally, or it is an equal distribution of auxin. Right? If the like here, if the light shines all around the tip of all around the tip, oxygen is distributed evenly throughout the cells in the shoot grow at the same rate because it's an evenly distribution. That's why they each and every cell of the tip will grow in the same rate. This is what normally happens with the plant growing outside. Oxygen work in the shaded area or less area, but the growth is seen in the area where the light has fallen. I hope this auxin function is being given. If I summarize it quickly, auxin is a hormone of a plant which controls the growth. And the location of the auxin production is the tip of the root and the shoot. In the shoot, auxin promotes the cell growth or cell elongation. It helps in the cell elongation, which is eventually leads towards the cell growth or the plant growth. And in the root, it inhibits the growth because the root needs to go towards the water and auxin. There will be less concentration of the auxin, so the growth will be inhibited, which will allow the root to go towards the gravity in search of the water. Okay, now there are two ways the auxin work. Uh, if if we with the respective of the sun, positioning of the sun, if the sun is on the top of the plant, which is providing its sun rays evenly on the tip, it means the distribution of the auxin will be even. How do they work? They are produced in the area of the tip, but they will work behind the tip. As soon as the auxin are released and they will start working behind the tip, the cell will elongate and eventually the cell will grow. If the sunlight is in top of the plant, it means the auxin are produced evenly. And if there's a certain direction of the sun, means the plant will bend towards it, right? And this is known as unequal distribution of the auxin.